Yeah, welcome to this video on the Elinchrom 19295 Li-ion battery. This battery pack was commonly used with the Ranger Quadra series as well as the ELB400, and it is controlled by two Texas Instruments controllers, of which is the more important the BQ80Z20A and also the BQ29312. And the BQ20Z80 has a feature which uses out of the battery quite commonly after, for example, a deep discharge. This was the thing in my case. After I returned from a 5-month stay abroad, the battery pack was inaccessible for me. And after another 1 year later, I finally started to investigate if I could open it again. And first I tried to charge the cells individually over the respective contacts and terminals with a lab power supply. This worked out well to recharge the batteries, and I found out that the batteries were still alive, but I couldn't bring the cell back to life. So here I show you the individual cell levels at their current charging voltage. You can check if your batteries are working that way. After I found out that my batteries were still working, with the help of two websites, one is Dave Takes Pictures, the other is Squidgy Fish, I learned that Elinchrom was actually using the Texas Instruments standard factory commands and passwords, and that I could access the controllers via an Arduino. The Arduino uses I2C protocols from their data bus and clock bus, and the Texas Instruments controllers use SM bus, which is basically the same protocol. But first I wanted to check the controllers for the state, and here I'm measuring the pin number 8 on the BQ20Z80, and it measures at 3.3 volt. And this pin, the VDDD pin, is the internal power supply, and it shows that this chip is still alive. The other chip, the BQ29312, is essentially controlling the charging process, and what I will comment on here is only the readout of the pins 3, 4, 5 and 6, which are designated at VC1 to VC4, and those show the readout of the controller of the battery cell. So VC1 measures the voltage across all cells of the battery pack, which is 15.8 volts. VC3 and VC2 are also additions of the cells. First 3 cells, then 2 cells, and eventually at VC4 you will see the readout of one cell at 3.9 volts. You can compare these levels that the controller thinks these cells are at if you measure across the terminals. Here I will show you measuring across all the cells, and it reads out at 15.8 volts. Now that we have tested that the battery cells are still intact, we can continue the question of how to transfer the data to the Texas Instruments controller, and for this we used a Arduino Nano controller in combination with a level shifter. The level shifter is important to guarantee that the Arduino's output on its data and clock pins is 3.3 volts, as is the voltage of the Texas Instruments controller. Some sources said that pull-up resistors would be required on the data lines on the A4 and A5 pin of the I2C protocol of the Arduino to connect with the SM bus terminals of the Elinchrom, which are on the SMBD and SMBC pins. And you also see them on the setup that I present to the camera, but actually when I first transferred the data, I didn't need to use them. And what you will see on the camera too is that I used an external power supply to power the level shifter to 3.3 volts, because I couldn't get clean 3.3 volts from my Arduino. If in your case you receive 3.3 volts cleanly out of your Arduino 3.3 volts port, you can just use it. After you connected the SDA and SCL ports of the Arduino on A4 and A5 with the Elinchrom SMBD and SMBC pins in the diagnostics port and grounded them, you're ready to use the script that I programmed to clear the permanent failure flag. All the keys used in this script are taken from Texas Instruments SLUU276.pdf file from pages 61 as well as pages 87 to 91 with the keys to seal and unseal the battery and remove the permanent failure flag. Now you can use the Arduino IDE, which is free to download. Open the script, set up your Arduino, and connect it to the Elinchrom chip. After compiling, you can just send the script, and after that, the permanent failure flag should be erased. Now after applying the script, you can check the outcome in the serial monitor tab at the bottom, and you should see that the permanent failure flag was erased. In my case, obviously the battery is already repaired, so I cannot demonstrate it to you. Well, thanks for watching. I hope this helped you restore your Elinchrom battery back to life. Bye bye!